Key features of quadratic equation part 2. All right. These can get kind of tricky sometimes. A goalkeeper punts a soccer ball. The trajectory of the soccer ball can be modeled by the function h of t equals negative 16t squared plus 48t plus 2, where h of t represents the height in feet of the soccer ball at any point in time in seconds t. A graph of the function is below. Okay. So if I'm looking at this graph, I first maybe want to label my axes. So this would be the height, this axis, and that would be in feet. And then this would be the time, and that is in seconds. Okay. So it asks, what was the initial height of the ball when he punted it? Okay, so that's referring to that y-intercept, like right at time 0, what's the initial height? So I'm going to zoom in here. It looks right here, which if this is 10 and there's 5 lengths, that would be 2. So the initial height of the ball when he punted it was 2 feet. Now the second question says, how high did the punt go? Okay, so now we're looking at the vertex. And this is nice because it actually gave us it, where this is. This is up at 38. This would be 38 feet. So that's how high it went. Now it says, what would be the appropriate domain? So domain is X, and this is where it gets a little, you really have to interpret it. You might say, okay, it's all real numbers. You might think, oh, it's all real numbers. It's going to keep going this way and keep going this way. Like, and I get that, but this is an application problem. You would never have a negative time. This axis is time. You can't say negative infinity seconds. It's not all real numbers. You can't have negative seconds. So we would start at 0, because that's when he kicked us at 0. We would start at 0, and then it wouldn't go through the ground either, the ball, right? It stops here. It stops there. So I would say an appropriate domain would be 0, between 0 and I'm going to put the full thing, 3.041. But you could say just 3 if we're rounding. But an appropriate domain would be between 0 and about 3 seconds. That would be an appropriate domain, right? Because anything past that 3 seconds, the ball would be underground. That doesn't make any sense, right? The height would be negative. That makes no sense. And it doesn't make sense for anything to exist before 0 seconds in the negative. So I'm going to say between 0 and 3.041 seconds. So that's the idea there. You really got to interpret some of this stuff. Okay. So D says, what would be the appropriate range? So ranges are Y. So I'm going to go off the same concept of this ball is never going to go below the x-axis, right? Like you're never going to have a negative height. The height, h of t, has to be greater than or equal to 0. It's never going to go below, but it does reach a maximum height of 38. So the range would be between 0 and 38. So yeah, I mean, these are a little bit, you really got to interpret some of this stuff. E says, over what interval was the soccer ball increasing in height? So it's increasing this whole time, right? But it doesn't make any sense for this part, because that's not really a part of the trajectory of the ball. This is just the function that models it, the graph that models it. So when is it increasing? It's increasing from 0. Remember, we're looking at the x from when he initially kicks it at 0 seconds to 1.5 seconds is when it's increasing. So when the time is between 0 and 1.5 seconds, and then it decreases from 1.5 seconds to that 3.041 seconds. 1.5 seconds when time is greater than 1.5 seconds, but less than 3.041. Okay, so yeah, I mean, this is an application problem with a whole scenario. We have this function kind of modeled for the equation, but you have to use your interpretation skills to answer these questions. Okay. I'm going to do 2. It says a model rocket was launched up in the air from the ground. The height of the model rocket can be modeled by the function h of t equals negative 5t squared plus 32t, where h of t represents the height of the model rocket in meters at any point in time in seconds, t. At what time does it reach? Okay, let me just highlight what's asking. At what time does the model rocket reach its maximum height? So we want at what approximate time does it reach its maximum height? Okay. It's not asking for the maximum height. It's just asking at what time it reaches the maximum height. So let me just reiterate that with a drawing. So if I were to draw this, so the model rocket is going to start like on the ground. It doesn't have a y-intercept. If I look at this function here, it doesn't have a y-intercept. If I plugged in 0 for time, it's going to be 0. So it's going to start on the ground, but that's beside the point. It's not really important for this question. So it's going to go up and then down, right? So this would be our time, and this would be our height. So we're trying to figure out at what time it reaches this maximum height. We're not trying to find like the vertex per se. We're not trying to find the y value of the vertex. We're not trying to find that height. We're just interested in the x value, the time, or in other words, the axis of symmetry. We're trying to figure out at what time it reaches that maximum height. So we only have to do the axis of symmetry formula. We only have to do negative b over 2a. So negative 32 over 2 times a. 2 times negative 5 is negative 10. So that would be 3.2. So the axis of symmetry is at 3.2. So this would be at 3.2 seconds. 3.2 seconds. That's when it reaches its maximum height. It's not asking for the maximum height. We don't have to plug in the 3.2 to figure out that maximum. It's just asking at what approximate time does it reach the maximum height, and that's at 3.2 seconds. So you really got to think with some of these. Okay. I'm going to let you go ahead and do 3. Just interpret the graph there. Okay. And number 4, I'm going to let you do 2, but I just want to talk about it really fast. Okay. So we're talking about building bowling alley with a different number of lanes, and the profit is based off of that function. So A wants to determine the interval, guarantee that the company makes a positive profit. So like it does say find the zeros as a hint. So basically, if I already kind of sketched this, just so that we're clear, this could be profit, and this could be lanes. So for a certain number of lanes, they're going to have a negative profit. Like obviously, if you have no bowling lanes, you're not going to make any money. You're going to have a negative profit. But after a certain number of lanes, you're going to start making a profit. And then if you have too many lanes, they'll be unused, right? If you have a bowling alley that has like 100 lanes, there's not going to be enough people to be on those lanes. So you're going to start making a negative profit. So you're trying to figure out the zeros on this. So you want to find the zeros with that equation. So I would use the quadratic formula for that. So remember, that's like a -1 for A. So use the quadratic formula I would use for that. And then B says, what is the optimal number of bowling lanes they should use to maximum profit? So this one's also optimal number of bowling lanes to maximize profit. So that's going to be talking about the axis of symmetry on that one. Okay, so I don't want to do them for you, though. I want to make sure you have practice to do it yourself.